Alright, so we're going to start looking at some advanced or more advanced implicit differentiation problems. So this question asks us, given that x squared plus y squared equals 25, it asks us to find the second derivative of y, or um, basically what we're trying to do is find the second derivative. So we're going to find dy dx first, and then we are going to differentiate that function and figure out what the second derivative would be. So we start off, we need to differentiate both sides with respect to x. So if we did both of these, this is going to look out of order, but you see what I've got there. You're going to differentiate 2x with respect, or x squared with respect to x. You're going to get 2x. You're then going to differentiate y squared with respect to x. So you're going to get 2y dy dx, and then you're going to differentiate 25, which that is just going to be 0. Now we are supposed to solve for dy dx, so my first step here is I'm going to subtract 2x from both sides, because I want to get my terms with dy dx by themselves. So you get 2y dy dx is going to equal negative 2x. And then I'm trying to solve for this. So I'm going to divide each side by 2y. And I'm going to get dy dx equals negative 2x over 2y. So this is like y prime equals. So this is the first step. So this is derivative 1. So I need to go about finding derivative 2. So what I'm going to get, so 2 starts off, and so this is like finding first derivative, and this is about the second. So the second derivative looks like this. We're going to have the second derivative is going to be equal to what? Well, since we have a function divided by another function, we have the quotient rule. So our quotient rule, we need to make sure we know what our high and low functions are. So this is high, this is low, and so we know that we have our high function is negative 2x, our d high is going to be negative 2, then we have our ho function is 2y, and our d ho function is 2 dy dx. Well, when we go back through and plug everything in, we know that this over here is dy dx. We're eventually going to replace it, but let's just do this one part at a time and put everything together. So remember, it goes ho d high, so we've got, it's going to be 2y times negative 2 minus high d ho, which is negative 2x times 2 dy dx divided by ho squared, which is going to be 2y squared. So we're going to need to go through and simplify this. So we get negative 4y. We're going to get, this is going to be a plus because of the two negative signs. We're going to get plus 4x dy dx, all divided by 4y squared. Well, I need to replace this dy dx with what I know that it can be, which is 2x times 2y. So when I go through and replace this, I'm going to get negative 4y plus 4x times negative 2x over 2y, which is the same thing as negative x over y. I just haven't simplified it yet. And then this is divided by 4y squared. So we get negative 4y plus, minus. We're going to be a minus now. If I simplify this a little bit, I'm going to get 4x squared over y divided by 4y squared. We can simplify this if we multiply, we can get rid of this fraction. If we multiply everything by a y, just to eliminate this, you become negative 4y squared minus 4x squared all over 4y cubed. Since there's a 4 in everything, we can actually get rid of all of these terms. and you're left with this as a simplified solution. Now, if you got confused in any of those last steps, just go back and follow me from here on. I ran out of room, but this is the way that you go about simplifying it. But the main part about this question is you're going to find dy dx. You're then going to repeat and find everything again, but you're going to need to replace the dy dx that comes up in the second derivative with what you got when you did it the first time. Another example of something that would be a little more advanced is going to be, finding a tangent line with implicit differentiation. So it says find the tangent line. We have this graph x squared times x squared plus y squared equals y squared. So we need to find what dy dx is first. They give us our point, so we need to figure out what the slope is from that point. So we are going to take the derivative with respect to x on both sides here. When we do this, think about this function here. I'm just going to rewrite this on the inside. I'm going to rewrite this as x to the fourth plus x squared y squared. I think it just makes a little bit more sense to just go ahead and distribute it and make things easier over time. At least I think so, instead of having to do a big product rule. So it's the same thing as this, I just distributed. So just make sure you follow that. So this, you should end up with 4x cubed. Now we've got to do the product rule here. So we're going to end up with x squared times 2y dy dx plus 2xy squared. And that's going to equal 2y dy dx. So if we simplify, we'll get 4x cubed plus 2x squared y dy dx plus 2xy squared equals 2y dy dx. We want to get all of our dy dx terms on one side, so I'm just going to subtract this over since I've already got one on the other side. You'll have 4x cubed plus 2xy squared equals 2y dy dx minus 2x squared y dy dx. And we always want to get these on the same side so that we can factor out our dy dx so that we can actually solve for what it is. So this, you'll end up with 4x cubed plus 2xy squared. This is going to equal our dy dx that we factored out times what was left over, which is 2y minus 2x squared y. And then eventually we just solve for what dy dx is. So we get dy dx that equals the other side, which is 4x cubed plus 2xy squared all over 2y minus 2x squared y. Alright, so we've got lots and lots of stuff going on here. So now we've got to go through and plug in our numbers so that we can figure out what in the world our slope is, so that we can actually go ahead and figure out, well, what we're going to have left. Okay. So our point was the square root of 2 over 2 and the square root of 2 over 2. So we need to go through and plug in these numbers. So we're going to get 4 times the square root of 2 over 2 cubed plus 2 times the square root of 2 over 2 times the square root of 2 over 2 squared over 2 times the square root of 2 over 2 minus 2 times the square root of 2 over 2 squared times the square root of 2 over 2. So lots of stuff going on here. So let's see what we can simplify. So instead of multiplying everything out right now, I'm just going to combine stuff and see if I can simplify anything, maybe make it make a little bit more sense. Because in this case, the x's and the y's are all kind of the same. It makes it a little bit easier than it might have been. So this is cubed. I then have 2 times the same thing. This is the square root of 2 over 2 cubed. Because these are the same numbers, I can stack them together. Then I've got 2 times the square root of 2 over 2. And then minus 2 times the square root of 2 over 2 cubed. Okay, well, I have at least a square root of 2 over 2 in every term, so I can cancel that. I have a 2 at least in every term, so that can cancel. So this simplifies to 2 times the square root of 2 over 2 squared plus square root of 2 over 2 squared over, this all makes a 1 there, and this just makes a square root of 2 over 2 squared. So we can even simplify this further. The top is 3 times square root of 2 over 2 squared, because there's 2 of these, plus 1. And this is going to be 1 minus square root of 2 over 2 squared. Now I want to go through and actually figure out what this giant number is. So I'm going to get 3 times the square root of 2 over 2 squared is the same thing as a half, or 2/4. So this is a half. And then I get 1 minus a half. So this is 3 halves over 1/2, which is the same thing as 3. So that big, giant, annoying number that we had simplifies simply to be 3. So now I can finally go and figure out what my equation is. So I know that m equals 3, and I know that my point is going to be the square root of 2 over 2, square root of 2 over 2. So I go through and make my line. So I've got y minus y1 equals m times x minus x1. And when I plug everything in, I should get y minus my y1 coordinate, which is the square root of 2 over 2, equals m times x minus square root of 2 over 2. And now I just need to go through and simplify and make everything nice and neat. So I got y minus the square root of 2 over 2. It's going to equal to 3x minus 3 times the square root of 2 over 2. If I add square root of 2 over 2 to both sides, okay, I'm going to get y equals 3x minus 2 over the square root of 2. Because I'm adding, basically imagine this as there are 3 of these, or there are 2 of these down here, or excuse me, there are 1 of these down here. So if I add 1, I get 2 over square root of 2, which just becomes square root of 2. So that is a really long problem. Finding the derivative and just making sure that you're taking care of the individual details is what's difficult there. It's a long problem. You have to stay very organized. So you have to know, first off, to make sure you're doing the right rules, to make sure you're solving for dy dx the right way. I mean, you can see that most of these numbers just repeat, I'm just copying down new numbers. I made my life a little easier down here, or at least to me, I thought I did, by not going through and cubing all these numbers and getting all kinds of crazy stuff. Because they were all the same numbers, it made things a little easier. I just got to pay attention to the details and take it step by step. The more you write out, the fewer mistakes that you can actually make. You just have to take your time. Finding the slope to be 3, and then once you have your point, we've done this plenty of times, just taking your time, making sure that you're combining things the right way, and making things simple. So longer problem, but it's just like the other ones. You find your derivative, you find out what your slope is at that point, and then you find your tangent line.